We introduced domain and range in the last section, but let's get a little more in depth about domain and range and review interval notation. So domain, like we said before, is the set of all possible inputs, and usually that means all the X values. And range is the set of all possible outputs, usually that's the Y values. So let's review interval notation and also set builder notation, which might be something that's completely new to us, possibly, and maybe interval is too. Hopefully remember that set means curly brackets. So like when we solve an equation, we've been talking about the solution set. Interval is how to write a range of numbers. A set is really when we make just a list, but an interval, like this one is an example here, this is just a way to say we're all the numbers between 10 and 15. So if we are, like this one is less than or equal to, less than or equal to, greater than or equal to, the equal to means we use square brackets. If we're just less than or greater than and we don't touch the endpoints, we use parentheses. But otherwise, an interval is just the low number, comma, the high number that we're between. That's it. It's just a way to like have a shorthand to say I'm between 10 and 15 and I can equal either the endpoints. All right, so in this case, it's a babysitter who will work for between $10 and $15 an hour. So that's interval notation. Set builder notation is this very specific kind of way. It is a set, there's curly brackets, but it's written as the set of all X, and then this vertical line is read such that. And then we put some property in here. So it's the set of all X such that, and then you put maybe X is between 10 and 15, or X is greater than 2. So in this one, let's do that. This number line is representing X is greater than 2. I know it's not greater than or equal to because they put a parenthesis here. Now, if we learned this in high school or on ALEKS, you might have seen this with an open circle and then the arrow. That open circle is the same as this parenthesis, but our textbook and PCC in general likes to use parentheses and square brackets instead of open circles and filled in circles, because then it sort of goes right along with the interval notation. So this parenthesis means I'm not actually touching 2, but I'm anything bigger than that. So it might be 2.0001. That's in there. We're using decimals when we use an interval. It's not just whole numbers between the values. So the interval for being bigger than 2 is to go from 2 to infinity. Because this arrow, if it's going in the positive direction, that's positive infinity. If we go all the way down in the negative direction, that's negative infinity. Let me just write those on my number line. So this is the set builder notation, that with the curly brackets and this vertical line that's read such that, and this is an interval just to say I'm between 2 and infinity if I'm bigger than 2. All right, maybe new stuff, maybe a review. Let's try another one. B, all real numbers less than or equal to 8, not sure why the big gap in there, but we'll just roll with it, can be expressed. Well, in a set builder, it'd be the set of all X such that, and this time I'm less than or equal to, so X is less than or equal to 8. It's just a very formal way of writing that. The number line is that I'm going below 8, so that's negative infinity to 8 being filled in. One sort of trick that helps some people is that if you see a greater than, it's like an arrow pointing to the right, so we're filling in to the right. A less than is an arrow pointing to the left. That might help. But in either case, our interval is -infinity to 8, and we're using a square bracket because it's equal to 8. Now, I don't put a square bracket on infinity or -infinity because I can never equal infinity. It's more like a concept. It's not a number I can actually touch. So infinity and -infinity always get parentheses, but the numbers, we have to decide whether we can equal them or not. All right, let's look at this one. So now this one is using like an open circle. And what this is saying, let me write it in Set Builder. So it's all real numbers except 4. So we're going to say the set of all x such that, and then just x cannot equal 4. So it's everything except I can't touch 4. And that's what that open circle is saying. It's like we just plucked out a point off the number line. The interval for this, well, we know all the way to the left is -infinity, all the way to the right is +infinity. So it's going to be -infinity to 4. I'm not touching 4 because I can't equal 4. That's the whole idea. And then we use the union to skip over 4. So that capital U is red union, and it's sort of like an OR. So it means I'm either less than 4, -infinity to 4, or I'm bigger than 4, 4 to infinity. That's really all this is saying. It just looks, maybe a bit overwhelming if it's your first time seeing something like this. But with practice, hopefully it starts making sense that we just mean from -infinity to 4, we skip over 4, and then 4 to infinity. All right, let's try this. We have, for the given graph, write the solution in set notation. Now, if they really just want it to be 2 or 4, that would just be 2, 4. If they were talking about being in between, well, then we would need an interval, right? So solution sets like this is either 2 or 4, nothing in between. If we wanted the numbers between 2 and 4, that would be this interval. So using curly brackets and using square brackets totally changes the context. So this is every number, including all the decimals, between 2 and 4. Including decimals between 2 and 4. So there's a big difference between a set with curly brackets where we're just making a list, means it's only numbers in this list that we're including, whereas an interval is including every single number between those two. It would be like the shaded part. So hopefully that's, making sense. If these were open circles and we didn't want to include the endpoints, that's when we'd use parentheses for our interval. Okay, let's try another example. For each of the given interval graphs, express in interval notation and set builder notation. So it's more like the same. With this method of using square brackets instead of the filled in dots that we might be used to from high school or from Alex, I think it's actually easier with the square brackets to know, oh, well, the interval, we're just going to use those square brackets because that's what's on the line. So 2 to 5, that's our interval. Our set builder notation, that means use curly brackets, the set of all x such that, and we're going to write that x is between 2 and 5, but in less than or equal to's. I'm using equal to because the square brackets means I can equal the endpoints. So all three of these, the picture, the interval, and the set builder notation, all say that we're including the numbers between 2 and 5 and including 2 and 5, the endpoints. Okay, a little strange maybe, but hopefully we're getting used to it. Let's try this next one. Now there's this gap between it. So anytime there's this gap, we're going to use a union, that OR. I'm going to label my neg infinity and my pos infinity, because basically we just need to go through here and write this as an interval. So I'm going to go from neg infinity to 1, and I always use parentheses on neg infinity. And the 1 has parentheses. That means it's like an open circle. We're not including that endpoint. Then union 4 to infinity. In set builder notation, I would say it's the set of all x such that x is less than 1 or x is greater than 4. And we need to use that word or because we don't have just one nice in-between line. We have two different pieces.